Hello student, welcome to EPG Pathshala. I am Dr. Anil Kumar from Center for Medical Biotechnology, MD University Rohtak. Today I am going to talk on a module nanotechnology and its application under the paper Animal Cell Biotechnology. So what will be the learning objective and outcome of this particular module? After the completion of this module, you should be able to search, read and present basic of nanotechnology literature applied to a particular problem domain. You will be able to demonstrate a working knowledge of yours about nanotechnology principle and the industrial application. You will be able to apply a key concept in material sciences, chemistry, physics, biology and engineering to the field of nanotechnology. You also should be able to determine actually where there is a placement of atom in a pattern to produce a desired structure. Now let's introduce nanotechnology. The term nanotechnology comes from two words, a Greek word nano, which is referring to the billionth, and the word technology. The nanotechnology is the act of manipulating the material at very tiny scale, that is at the level of atoms and molecules. It refers to constructing and engineering the functional system at very micro level, or we can say at atomic level. It generally considered to be at the size below zero point 0.1 micrometer, or we can say 100 nanometer. A nanometer is 1 billionth of a meter, roughly the width of 3 or 4 atoms. As you know, average human hair is about 25,000 nanometer wide. It brought emergence in the field of energy medicine, electronics, computing, security and materials. This nanotechnology, also known as the molecular manufacturing or manufacturing based on nanotechnology. So first, going to nanotechnology discussion, we must know what is the nanoscale. As you know, Earth is having a diameter of 12,756 centimeter, and a football you can see in a picture which is a diameter 32 centimeter, and there is a nanotube which is a diameter 0.7 centimeter. So you can compare the size of all of one. There is a football which is 10 million times smaller than the Earth size, and that nanotube which is a 1 billion times smaller than that football. So this is the particular level at which the nanotechnology works. So how this nanotechnology has evolved? In 1974, the Japanese scientist Norio Taniguchi of the Tokyo University of Science was the first to use term nanotechnology in a conference. Nanotechnology and nanoscience got a boost in early 1980s with the development of cluster science and the invention of scanning tunneling microscope, STM that is. The STM, that is scanning tuning microscope, is an instrument which can be used for imaging surfaces at the atomic level. In 1985, the discovery of fullerenes was done. We will discuss about them later on. In 1989, the IBM researcher Don Igler was the first to manipulate atoms using a scanning tunneling microscope. He used 35 genome atoms to spell out the IBM logo. In 1991, discovery of carbon nanotubes by Japanese scientist Sumio Lijima was done. In 2009, an improved walking DNA nanorobot was invented. The designing of small protein that can perform the function of natural globulin protein was also discovered. In 2011, the first programmed nanowire circuit was used for nanoprocessors. So why nanotechnology? Why want to study the nanotechnology? Why want to explore the nanotechnology? Because it allows the placement of small structure placed with precision, simplicity and low cost. It leads to the economic growth, it enhances the national security, it improves the quality of life by providing certain appliances which can work at a very high speed, and it leads to the employment. The nanotechnology itself has a various component which can be divided into tools, material and devices. As you know, there are the three components of nanotechnology. First one is tools, then nanomaterials and devices. So coming to the first component, that is tools. Nanotechnology tools include microscopy techniques and equipment that permit visualization, manipulation of items at the nanoscale. Such as we can take example of cells, bacteria, viruses, and to detect the single molecule to understand the nature of science. The range of tools include AFM, which is the atomic force microscope, STM, scanning, tunneling microscope, molecular modeling software, and the various production technology which is a part of nanotechnology tools. So coming to the second component, that is the nanomaterials. The most common nanomaterials used in nanotechnology are fullerenes, that is the carbon-60, and carbon nanotubes. So what are the fullerenes? A fullerene is any molecule composed entirely of carbon in the form of a hollow sphere, ellipsoid or tubicle. Spherical fullerenes are also called as bulky balls. They resemble the balls used in a saucer. They are similar in structure to graphite, which is composed of stacked graphene sheets of linked hexagonal rings, but they may now also contain pentagonal or sometimes they can be a heptagonal rings. Carbon nanotubes. The carbon nanotubes are the strongest and the stiffest material discovered till to date. They are also known as bucket tubes. They are allotropes of carbon with a cylindrical nanostructure. The nanotubes have been constructed with a length to diameter ratio of up to 13 crore 20 lakh is to 1. Its name has been derived from long hollow structure with the walls formed by one atom thick sheet of carbon known as graphene. The carbon nanotube, this serves as nanowires in molecular computer by quantum property called electron tunneling. The carbon nanotubes are of two types, single walled nanotubes and the multi-wall nanotubes. So coming to the single walled nanotubes, the single walled nanotube have diameter close to 1 nanometer with a tube length that can be many millions times longer. Its structure can be conceptualized by wrapping a one atom thicker layer of graphite called as graphene into a seamless cylinder. The wrapping of graphene is represented by a pair of indices, that is N and M, called as chiral vector. It is an important variety of carbon nanotube because they exhibit electric properties. The second type of nanotubes are multi-walled nanotube. They are consist of multiple rolled layers. They are also known as concentric tubes which are made up of graphite. Two important described model for construction of multi-walled nanotubes are Russian doll model and parchment model. According to Russian doll model, sheets of graphite are arranged in concentric cylinders. In parchment model, single sheet of graphite is rolled around itself like a scroll of parchment or a rolled newspaper. The third important component of nanotechnology is devices. There are two classes of miniature device that are commonly associated with nanotechnology, that are the nano device and the micro device. The both devices actually very in their size at the micro level or nano level. So in this slide we are going to discuss about the construction of nanomaterial, how we can synthesize this nanoproduct. There are two approaches for synthesis of nanomaterials and the fabrication of nanostructures. These two approaches are known as top-down approach and the bottom-up approach. Now come to the first approach, that is top-down approach. Top-down approach refers to the slicing or cutting of a bulk material to get nano size material. So in this particular approach we are going from complex to simplest form. This is similar to making a stone statue. You take a bulk piece of a material and modify it by carving or cutting stone until you have made the shape you want. The particular process involves material wastage and is limited by the resolution of tools you can use, which cause significant crystallographic damage to the process pattern. The example of this kind of approach include various type of lithographic techniques. The bottom approach, it acts in a opposite way. The bottom approach refer to the buildup of material from bottom. So we are going by atom. So we are going from simplest to the complex form. The molecule by molecule or cluster by cluster or atom by atom. These are the three principles of bottom up approach. This is equal to the same approach one would take to build up a house. So when you are interested in building up a house, one take a lot of building blocks, then put them together to produce a final bigger structure. There is a less wastage. This is an advantage of bottom approach, and the strong covalent bond will hold the constituent part together. The good example of this kind of approach is found in nature. All the cells use enzymes. Enzyme which basically are the biocatalyst which produce DNA by taking the component molecule and binding them together to make the final structure. Nanotubes. Nanotubes is one of the most commonly used product that has been given by nanotechnology. The nanotubes, they have greater mechanical strength per unit volume than that of conventional materials. Electronic property of nanotubes have made them used in a flat panel display in TVs and monitor, batteries and other electronic devices. The other nanoproduct such as nanofilm, the different nanoscale materials can be used in thin films to make them water repellent, anti-reflective, self-cleaning, ultraviolet or infrared resistant, anti-fog, antimicrobial, scratch resistant or electrically conductive. The nanofilms are used now on eyeglasses, computer display, and cameras to protect and to treat surfaces. The next nanoproduct is nanoscale transistor. The transistors are electronic switches devices where a small amount of electricity is used like a gate to control the flow of larger amounts of electricity. In computer, the more transistors, the greater the power is. The transistor size have been decreasing, so computers have become more powerful. Until advent of nanotechnology, the industry's best commercial computer chip with transistor having size of 65 nanometer has been produced. The recent announcement indicate 45 nanometer feature technology soon will be here. The next nanoproduct is a nanowires. A nanowire is a nanostructure with a diameter of nanometer 10 raised to power 9 meter. Alternatively, nanowires can be defined as a structure that have a thickness or diameter restricted to tens of nanometer or less. Many different types of nanowires exist, including metallic, for example nickel, platinum, semiconducting, for example silicon and gallium is there, and some are insulating. example like silicon dioxide, titanium dioxide. The molecular nanowires are composed of repeating molecular units, either organic, for example DNA, or it can be a inorganic. The nanowire could be used in the near future to link tiny component into extremely small circuit. Using nanotechnology, such component could be created out of a chemical compound. The next nanotechnology product is nanolithography. Nanolithography is the art and the science of etching, writing, or printing at the microscopic level, where the dimension of characters are on the order of nanometer. These include various methods of modifying semiconductor chips at the atomic level for the purpose of fabricating integrating circuits. The instruments used in nanolithography include SPM, that is a scanning probe microscope, and AFM, that is a atomic force microscope. Either the SPM or the AFM can be used to etch, write, or print on a surface of a single atom in a dimension. The one of the most common product, or we specifically say nano product, that is a nanocomputer. The nanocomputer is the logical name for a computer which is smaller than microcomputer. This is based on nanotechnology. In fact, one of its major application. More technically, it is a computer whose fundamental parts are no bigger than a few nanometers. For comparison, the smallest part of current state of the art microprocessor measures 28 nanometers as of 2012. Nano components are very efficient, and therefore these nanocomputers will be at the high speed and they will be having high degree of efficiency. The next nano product is a nano sensor. It is another wonderful invention of nanotechnology. These are biological, chemical, or surgical sensory edges or points which are used to detect and transfer nanoparticle information to the other devices of microscopic or macroscopic world. Their basic purpose is to develop nanoproducts such as silicon computer chips and nanorobot fabrication. The nanosensors work with their special sensory ability which can detect information and data. Their arrangement is like ordinary sensor, but nanosensors are developed at nanoscale which make them different from ordinary one. The most of the futuristic product of nanotechnology which will be the part of future, that is a nano robots. Nano robots are the robots that are programmable, whose components are at or close to the scale of a nanometer. Basic nanomachines are already in use. Nanorobots will be the next generation of nanomachines. Advanced nanorobots will be able to sense and adapt to environmental stimuli such as heat, light, sound, surface texture, and chemicals. And they will perform complex calculation. They will help to move, communicate, and they will able to work together. And they will be able to conduct molecular assembly, and to some extent they will be repair and even replicate themselves. These nanorobots can be used for medicinal purpose as well as technical purposes. One of the nanorobot that known as the dendrimus can be precisely programmed and used for wide variety of applications such as for treatment of cancer and other disease. Dendrimers carrying different materials on their branches and can do several things at once, such as recognizing disease cells, diagnosing disease state including the cell death. They can do the drug delivery, they can report location, and they can also report the outcome of any therapy. So, what are the benefit of nanotechnology? What are the significance of this technique? The benefit of nanotechnology are the largest one. The use list are there. Some are listed there, like less material consumption are there because we are using the material at the nanoscale. And the another benefit we are taking from this particular technique, more efficient energy generation method we can use, the greater computing power we can use, the high speed performance we can use, because when there is a less size is there, it can induce the high speed or high computing speed. Or it can be also used for drug delivery system, which can be used to for the various health treatment. The nano product can be used to control pollution. So nanoscopic devices or material manufacturing processes leave behind nanoparticles, which can infiltrate in the cells of humans, animals, and all living organisms that may be unprepared for the influx of artificial particles. Nanoscopic particles, when inhaled, could make their way into the brain via olfactory tract, and this raises some concern about possible health risks connected to the recent development in nanoscience and technology. So this is the one of the shortcoming of this nanotechnology, which can create the nano pollution. So student, let us summarize what we have discussed till now in this particular module. The nanotechnology which we have earlier discussed is the act of manipulating material at very tiny scale, which is at the level of atom or molecules. It generally considered to be a size below zero point 0.0 micrometer or 100 nanometer. As you know, a nanometer is a 1 of billionth of a meter and roughly the width of 3 or 4 atoms. The nanotechnology has allowed us to place small structure with precision and accuracy and with simplicity and the low cost. It has also contributed toward the enhanced economic growth, national security, and the further have improved the quality of life of mankind. Nanotechnology is a consisting of three components: tools, nanomaterial, and devices. Tools, basically it include microscopic techniques and equipment, certain production technology it include, and the remodeling techniques it include. The nanomaterial, basically part of the nanotubes we are using. The tools include, we are using microscopic technique like STM, AFM we are using. The important nanomaterial are being used nowadays are the fluorines and the nanotubes. There are two types of approaches we have discussed for the synthesis or the fabrication of nanomaterial. These were known as the top-down approach and the bottom approach. The top-down approach, which basically start from complex to simplest one. We are starting from complex molecules and going towards the atom. So in this approach, we are cutting a bulk material to get a nano size material, while in down approach, which work in a opposite way, in which we are going from simplest to the complex one. The number of nanoproducts have been synthesized using these two approaches. Some of the example like nanowires, nanosensor, nanocomputer, nanotransistor, nanofilms, nanotips. These nanoproducts have been used in various industries ranging from textile, cosmetic, electrical and health industry. Although nanoscience is proving a boon for mankind, but still it's suffering from shortcoming of a pollution, that is a nanopollution, which may affect human health to large extent. Thank you.